We're on lesson 3 of chapter 10, which is sample spaces. First, we're going to use a problem-solving plan. Then we're going to find sample spaces using a tree. Then we're going to find total number of outcomes using multiplication. So sample spaces is kind of just a fancy word for list making. We're finding all the different possible outcomes of an experiment. For example, here's a pretty common sample space. This is a sample space for choosing a card out of the deck. If you have the deck face down and you're choosing a card from the deck, this is a sample space of all the different outcomes you could get when you pull that card out. It could be any one of the 4 suits, and it could be any one of the numbers. So that's what we'll be doing today. We're going to try to find all the different outcomes from different kinds of experiments or events. We're also going to be using a shortcut as well, the fundamental counting principle. You could find the total number of outcomes in an event or experiment by multiplying the number of outcomes for each separate event. And here's an example where you would definitely want to use that. It asks how many total outcomes are there from drawing a card from 2 separate card decks. And that would really take you a while because all the different possible outcomes could be an ace, then a 2, an ace of hearts, then the 3 of hearts, an ace of hearts, then the 4 of hearts, an ace of hearts, then the 5 of hearts. It would be a lot to count and actually draw out. It would take much more room than this screen has. Thankfully, we have a shortcut for that. We can multiply the number of outcomes for each separate experiment. So there's 52 outcomes from the first deck because there's 52 cards, 52 outcomes from the second deck. Multiplying those together gives us 2,704 different outcomes. And yeah, that would have taken us a while to count. This is a little bit of a simpler one. It says Lucia flips 2 quarters at the same time. What are the possible outcomes? How many outcomes are in the sample space? Our first step in solving a problem is always to understand the problem. What is it telling us? Well, I know that there's 2 quarters. And I know that for each quarter, it could either land heads or it could land tails. So now we need to make a plan. How are we going to solve this? Well, I could make a list of all the different outcomes that could happen. So step 3 is to solve using that list. For example, let's say that first quarter was heads. It could be heads again for the second quarter. So this is one outcome. The second outcome would be heads, and then the second quarter being a tails. The third outcome, it could be tails for the first one and heads for the second one. And the fourth outcome could be tails for the first one and tails for the second one. I can't think of any other outcomes that I haven't already listed yet. That's because this is all there are. So we just listed the total of possible outcomes. Now we need to determine how many there are. Well, it looks like there are 4. Now we can find sample spaces using a tree. I like this method. It says Tom spins a spinner A and spinner B. What are all the possible outcomes? How many outcomes are in the sample space? So spinner A has a red color, a blue color, and a green color, and spinner B could either land on 1 or 2. By making trees, we start with one outcome. For example, let's say we had red. And once it's landed on red, there are 2 outcomes for spinner B. There is 1 and there's a 2. The other outcome for this one would be blue. When it lands on blue, spinner B could either be 1 or it could be 2. It also could land on green. When it lands on green, spinner B could either be 1 or 2. So by making trees, we've found all the different kinds of outcomes that could happen with the sample space. So by counting all the different branches, 1, 2, 3, 4, 5, and 6, I count 6 total outcomes. Now we can use that fundamental counting principle, where we see that you can multiply the number of outcomes for each separate event. We could have done that here by multiplying 3 times 2 to get 6, but I wanted to use the tree just to show you that method. It says, in a game, each player rolls a number cube and spins a spinner. The spinner is divided into thirds, numbered 1, 2, and 3. How many outcomes are possible during one player's turn? So let's focus on each separate event. We have rolling a number cube, and we have spinning the spinner. For the number cube, there are 6 possible outcomes, 1, 2, 3, 4, 5, or 6. For the spinner, there are 3 total outcomes, 1, 2, or 3. So by using the fundamental counting principle, we can multiply those and save us time and get an answer of 18 outcomes.